Okay, the mic was muted. Well, at least you know who it is, right? You know who it is. Protons, neutrons, electrons. Notation. Okay. Mass number, protons plus neutrons. The one at the top, the one at the bottom. Atomic number equals protons. That's the elements. That was correct. Example of isotope. Key idea: isotopes, same elements, same atomic number, different mass number. So the number at the bottom. No, one at the top. So for technetium, bro, you go somewhere here, bro. So for technetium, Z must stay 43. A must change. So for technetium, Z must stay 43. Must change. Example 9043 TC. Okay. Why this works? Same protons, different neutrons. This is a valid isotope. Wait. Uh, same. So, does it even matter? Like, I can't just give any number? Is that how it works? I'm confused on that part. Same mass number, 43. No. Same mass number, the 98. Different atomic number. Different elements. A must stay 98. Z must be different from 43. Example, molybdenum. Molybdenum. Can I simply change just the to any number I want. Rules on how those numbers could be changed. Also, okay, also the atomic number is different, but those aren't of the given examples. What? Okay, anion should be having minus, right? Let's clarify isotopes and isobars properly. Isotopes definition: same atomic number, same element, different mass number, different number of neutrons. Atomic number cannot change for isotopes. You change Z, it becomes different element, not an isotope. Mass number changes freely, but it must correspond to real possible combination of protons. Protons. Let me see that example. Looks like I did not get an example for that. Molybdenum. Mm-hmm. I need to bring my tablet, the Holy Bible. The Holy Bible of the modern era. Don't waste time, please. Is my face that dry? Is it that dry? You know what? My brain is a little bit stupid right now. I cannot imagine the numbers. Can't stop, won't stop, cause I got sick and I'm not yes. What did I write for intensive extensive properties? Internal properties of a compound's external elements bonds. External properties that can display as affected by the compound. Melting point, boiling point. That was far off, bro. What's it called? So element A X, no, element X with a atomic mass number, protons plus neutrons. Z atomic number. Protons. X element. Okay. I do not endorse this, okay? I couldn't find coffee today, that's why I'm using this. That's the most saddest thing I ever said today. Okay, I need to remember that. Electrons equals protons. Now, isotope. Isotope. Isobar. Isotope is same atomic number. Protons plus neutrons. That's atomic mass. What? Yeah. Atomic number is just protons. Okay, okay. Same atomic number, protons. Protons. So isotope has same atomic number, that is same number of protons, but different mass number. So the number of protons should stay 43. Neutrons. So can I 43 TC, or should I show something so example 98 TC 43. TC 4399 or TC 9743. For isotopes, you do not need to write. The mass number itself tells you the total number of protons, so it already reflects the difference in neutrons. The difference of one neutron automatically implied in writing. You don't need to add anything. Just write the new mass number. That's sufficient. Okay, so change in number of neutrons. So that's for isotope. Now for isobar. Same mass number. Neutrons plus protons. Different atomic number. Number of protons. So example 98TC43. Mm. 30 minutes? God damn it. Focus, 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 focus. So now the mass number is gonna stay same. So 98 TC. So 98 TC. It's not TC. It's gonna be something else like molybdenum. We got molybdenum. Molybdenum has 42. So so 42 is the number of protons. Now to get same mass number, it's gonna need to have more neutrons than usual, right? Yes. That's a common point of confusion. Let me clarify. For isobars, mass number is same, atomic number is different. This means the number of protons change, therefore the number of neutrons also change to keep A equals Z plus N. There, what? Number of neutrons adjust. Isobars, the proton number changes, not the neutrons directly. Neutrons change only as the consequence of. Wait. Oh my! I don't know if it's too much Red Bull. My mind is just. Isobar. So the neutrons are just automatically protons from. So here too for isobars 2 there is no electron, so no. What? Sis, there's sis no. Dude, it was that simple. So now, is radioactive. Radioactive decays for beta decation. Write down the reaction equation of product of this decay. Okay, I need the answer for this one. Tell me it's copied. No. There's sometimes saying, yeah. Let go up. I wanna celebrate and live my life. Saying, Ow. Let me see, set a time for 15 minutes. Beta decay. Neutron converts into a proton emitting beta particles. Neutron to proton, okay. Atomic number increased by emitting a beta particle and an anti-neutrino. The atomic number of protons increases by 1, but the mass number stays the same. How? How? Oh, it's just the one neutron goes to proton. That's it. You know what? That's really interesting. Like, the mass number stays the same, but there's a radiation coming out. So neutron is actually something that holds negative charge. I wouldn't say negative charge, but radiation. My mind is going radiation is something similar to an atom, electron. Something has a wave, it's like a wave function, it has the wave properties of an electron. Radiation should have a wave properties of an electron. Siri just keeps on listening to me. I did not ask this. I did not ask this. I'm gonna take it all. It's not the music I'm going for. No, not this, bro. Do I gotta search it? Atomic number increased by okay. Not the mass number, atomic number. Put it in. Not the mass number, just the atomic number. During a beta decay, beta minus decay, the neutron converts to proton, releasing what? Releasing beta particle, emitting a beta particle and an anti-neutrino. Okay. Put it in, boy. Devoto did. I appreciate you for checking out the stream. So the reaction is is this. This is usual case for radiation. Does it just beta decay? Beta minus decay is one of the common case. Beta plus decay, positron emission. A proton converts to a neutron. Emitting beta plus particle, positron, and a neutrino. Gamma decay, nucleus emits a high energy photon. I mean nucleus, you mean protons and neutrons, right? Only energy is released, okay. So the rule of thumb is beta minus. But okay. From the looks of it, most studies, particles are, most of these radiation, the mass number kind of remains the same. Kind of. Not exactly. That's how ChatGPT is going to respond. Not exactly. Describe shortly atomic model of Bohr. Fuck you. Why do you gotta ask that? It's not even relevant. Atomic model of Bohr? Fuck Bohr. I mean, I respect the guy for trying, but come on. Not quiet For all of them, it depends on the type of decay. Alpha decay, mass number decreases by 4, atomic number decreases by 2. Example, mass number decreases by 4. Mass number decreases by 4. How? Neutrons, protons. It's either 4 neutrons or 4 protons, or 2 neutrons or 2 protons, or 3 neutrons and 1 proton, or 3 protons or 1 neutron. Atomic number decreases by 2, so it's 2 protons, so it's 2 neutrons. So for alpha decay, okay. No, I'm not gonna challenge. Close like that. Tomorrow's radiation. Mass number decreased by 4. Mass number is neutrons. Atomic number. These are protons. So U equals 92. Let me see. 92, we got 90 thorium. 90 plus 2, 94. Is it thorium though? Yeah. It is a isobar of thorium. If I understand this right, it is an isobar. Wait, isotope. Isotope. 15 minutes, okay. Exactly. Yes, 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 yes. Beta minus isotope of thorium. So alpha decay, 2 protons, 2 neutrons. Oh! What's the next one? Beta minus decay. Mass number stays the same. Okay. So neutrons plus protons. But there we go. We got the twist. Atomic number decreased by 1. One proton, neutron. So one proton changes to neutron while releasing beta minus and neutrino. CCO. That's not a good looking carbon. Where's the carbon? Carbon 12. So here one so we go to boron, but it's still not usual boron. This boron got more uh from the looks of it, it got more neutrons, so its atomic or its mass number is higher, so it's a it's an isotope. Isotope. Gamma, gamma. I don't need to look too much into gamma. Gamma. Oh, this is where neutron to proton, beta plus is proton to neutron. That's good. I remember during my exam, one kid asked, "Is it the beta minus or is it beta plus?" I was like, "Shut the fuck up." But seems like that was a good question. Who am I to judge these kids? Just a minute. Okay. Come on, man. Get this shit together. Devoto did. I'm guessing you're not on the stream. I'm gonna refresh the chat, cause you know, cause it's gonna be look smaller, smaller. I got this correct. So if we were doing this, beta minus, it's gonna be beta minus is protons to neutrons, right? No, beta minus is neutron to proton. Yeah, I got that wrong. Okay, I was like, what the? Whoa, atomic number decreases. Increases, yes. So, mass number stays the same. Where is TC? Mass number remains the same. Neutron to proton, so plus ruthenium. Bum bum ba bum 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 ba bum 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 ba bum. Electron emitting beta minus particle and a neutrino. Emitting beta minus and anti neutrino. Mm-mm. Beta minus antineutrino. Now let's go for beta plus decay. Beta plus. Proton to neutron. Emitting beta plus and the neutrino. Yeah. Okay, gamma, nothing happens. Okay, let's go for the next. Describe shortly the atomic model of Bohr. I never expected to see this type of question because these models weren't, but looks like it might be asked. So not just for the Bohr model, can you also answer for other atomic models too? Because you never know what they ask. Hmm. Here's a concise summary of the main atomic model you might need just to limitation might need and their limitations. Dalton's atomic model. What did they ask? It was Bohr. Description: An atom is a solid, indivisible particle. Elements consist of identical atoms. Chemical reaction rearrange atoms. Cannot explain isotopes. Cannot explain the internal structure of an atom. Thomas Plum Pudding. I think I explained the plum pudding model, right? Model failed. Bohr's atomic model described how uh, atoms in which electrons revolve around the nucleus. Okay. Oh, oh, that was Rutherford. I mean, Bohr did have that. I need to bring my seat up. Ow! Description: Atom is a solid, indivisible particle. Elements consist of atomic orbitals. Atomic identical atoms. Chemical reactions rearrange themselves. Cannot explain isotopes. Cannot explain. Oh, come on! Don't just read. Understand what you're reading, boy. Am I schizophrenic? Don't get distracted, boy. Rutherford atom has dense positively charged nucleus, electrons orbit around it, most of the atom is empty space. Cannot explain why orbiting electrons do not spiral into the nucleus. Classical physics predicts collapse. Cannot explain discrete atomic spectra. Bohr model. Description. Electrons move in a fixed circular orbital around the nucleus. Electrons can jump between orbits by absorbing slash emitting energy. That's the Bohr model. Okay. Works only for hydrogen like atoms, false for multi electron atoms, cannot explain the fine structure, electron spin, and chemical bonding. Quantum mechanical model, Schrödinger Heisenberg. Heisenberg? Description. Electrons are described by wave functions giving a probability distribution rather than fixed orbits. Energy levels are quantized. Electrons are described by wave functions giving a probability distribution rather than a fixed orbits. Energy levels are quantized. Does not give exact electron paths, only probabilities. Conceptually harder to visualize than Bohr or Rutherford. Does not give exact electron paths, only probabilities. Conceptually harder to visualize than Bohr or Rutherford model. We do have some limitation with the model that we have right now. You know what I propose? I propose solar system. The fuck you just say, boy? Which of these compounds? I did that. I knew how to do that. Top, bottom, left, right, that was correct. Therefore, more protons on the nucleus, resulting in a stronger nuclear pull. Name 3 general properties of ionic compounds. Oh, that's the one I missed. That's the one I now know, at least what I think I know, based on the model of ionic band. Now, what are the models? Lewis structure, VSCPR, MO, valence bond on the other. Please draw the I'm still a bit confused on Lewis structure, but we're better than before. I know this. I know this. This one, I think it's easier to understand. This one, I was so stupid I forgot. If I did that, maybe that would make a lot of big difference. This one is really important, and please give the definition of acid and base. Uh-huh. Third law of thermodynamics. My eyes are watering, bro. Hmm. I don't think I have to remember the year. Nah, fuck that. I got 15 minutes. Wait. Limitations of atomic models. Dalton's atomic model. Atom is a solid, indivisible particle. Elements consist of identical atoms. Elements consist of identical particle identical atoms, not particles. What, dude? Are you seeing something that's not there? Are you schizophrenic, dude? Okay, identical atoms. Song is not good. Don't look back. What's this? Indivisible particle. Elements consist of identical atoms. Chemical reaction rearrange atoms. Chemical reactions rearrange atoms. That's the Dalton's. Dalton, the guy with the specs. Limitations. Cannot explain isotopes. That's the limitation? I don't think so. I think there are better limitations. Isotopes. Cannot explain the internal structure of an atom. Okay, that makes sense. The internal structure of an atom. Electrons, protons, neutrons. Electrons, protons, neutrons. Can I shape this Philip? Thomson's plum pudding motto. So after Dalton, it's Thomson. I don't know if. Yep, the guy with the specs. Atoms of same elements are not identical in mass. In the cases of isotopes, okay, that was right. Uh-huh. Okay. Mm-hmm. So GPT was kind of correct. Okay. Okay. Yeah. Don't get me wrong. I'm hearing a lot of shit, so I don't want to make mistakes. Why do I keep using the word you know? Atom is positively charged sphere with negatively charged electrons embedded like plums in pudding. Oh, I got a new way to write it. That's cool. That's cool. Atoms charged spheres with negatively charged electrons embedded like plum in pudding. Oh, fuck. Mm-hmm. Limitations. Cannot explain the result of Rutherford's gold experiment. Gold experiment. Gold foil experiment. I missed the word foil. Cannot explain atomic spectra. Line spectra of elements. Rutherford's nuclear model. Atom has a dense positively charged sphere. No, positively charged nucleus. I'm scared, man. Electrons orbit around it. Most of the atom is an empty space. Limitations. Cannot explain why orbiting electrons do not spiral into a nucleus. Don't spiral into the nucleus. Cannot explain discrete atomic spectra. I mean, that Thomson also didn't know it. Okay. Atomic spectra. Those parts are so weird, the atomic spectra. Bohr model. The Snaggle Fluster. Hi, can you explain to me something? Oh, well, I appreciate you for checking out the stream. Well, right now I got an exam tomorrow on general chemistry and I was looking into question paper and this was the question I was looking at. Describe shortly the atomic model of Bohr. It relates. I'm guessing it relates to you. Are you studying chemistry some way? Yeah. So I had this question in my exam. Oh, what the Bohr magneton in inverse meter per Tesla. Okay, that's too much for me, okay? I don't understand what you just wrote, but right now I was looking at all the older atomic models and their limitations. The first was Dalton, then we got Thomson, then we got Rutherford, then we got Bohr, then yeah, after Bohr it was the quantum mechanical model. And when during my exam they asked me to explain Bohr model and I couldn't. How does this allow for vacuum of space having 337 ohms? How does this allow for vacuum of space? I'm sorry if I'm disappointed you. I don't know. I don't get this. How does this allow for vacuum of space having 337 ohms? Bohr's magneton in inverse meter per Tesla. Are you doing PhD or something? I don't know. I'm still in my bachelor, bro. And I failed general chemistry 4 times. So, yep. It's so weird. Some people just pass on the first try, some people keep on failing. Mm. Well, you gotta try until you get it. But the problem is, if I fail the fifth time, I'll be study banned from a university. So I gotta pass. Mm-mm. Bohr model. So what are these two comments you just put? What is that related to? Bohr magneton. What is that? Electrons move in fixed circular orbitals. Push through, brother. Yes, yes. This is not the end. Because it's all public and it's all here. Just have to find it. Are you talking about your comment or my exam? Bohr model. Okay. What is this, bro? Bohr magneton value. What is this value, bro? Value recommended. Standard uncertainty. Bohr model. Bohr magneton. There, that's the Bohr model, bro. It's the first time I'm seeing Bohr model like this. The Bohr model I know is okay. I mean, I don't know too much about the Bohr model. I gotta say that. Hmm. I don't know where to start. Like, it's just this number is fucking crazy. That's the numbers. Fuck the graphs and shapes. Oh, okay. What number are you talking about? What this number? Okay. It's a fundamental physical constant representing the natural units of magnetic moment for an electron. It quantifies the tiny magnetic field generated by an electron spin. Oh, okay. So you're telling me that's the variations as well, by the way. Okay, so you're telling me this number is shown by almost everything out there. Every atom, every electron in the atom. Mm-hmm. Interesting. I can give you the current atomic numbers. Atomic numbers of. Wait, what do you do, bro? Or sister, what do you do, human being? This is good stuff. Hmm. Bohr and atomic numbers are different. Yep, I could say I agree to that. Bohr and atomic numbers are different. Hmm. Are you allowed papers? Is it the exam? Exam is this. They just gave me a paper. I gotta write on that. That's it. This, this exam is like the first exam you get in the exam when you start the bachelor's. If you write my numbers down as NIST 2022, remember them. Okay. I mean, what the hell is this? Let me give it to GPT. What does this thing think? Hmm. I can give you the current atomic numbers also. I mean, yeah, sure. Oh, it's remember them. Yeah. Okay. I really gotta say, I really gotta say, Snaggle Fluster. You just introduced me to Bohr magneton and Bohr radius. I thought Bohr, the name Bohr, ended with the Bohr model. Okay. Hmm. I'm kinda new to this topic. Could you explain what these numbers mean? Sometimes energies are expressed as temperature in physics to show this how much temperature corresponds to another electromagnetic. Ah, damn. Snaggle Fluster just dropped a lore bomb. Okay. Yo, Clone Open Commander. I got your message. Everything okay? No, I was just wondering. I haven't seen you, man. Was good. Was good. It's too long. Snaggle Fluster. That's a lot of lore bomb, I gotta say. Value uncertainty units. God damn, son. Just use this. Boltzmann constant, Bohr radius, Bohr magneton. Yo, this guy just dropped a lore bomb. Hmm. Can you remember all of that by heart? I don't think so. I don't think so. There is uncertainty in the mass of carbon. Uh, Molar volume of an ideal gas. Molybdenum. Natural unit of mass. What are these? Well, better pray you do. Or no uni and an ass whooping. Okay. Okay, I mean, I understand that you gotta know these values. Mm-hmm. It's crazy, man. It's crazy. Hey, if your parents don't, your auntie and uncle will. Yeah, they would. Okay, Avogadro number is exact. Okay, that's good to know. That's good to know that Avogadro number is staying still. Mhm. It's his PTSD gave that year. It came from a soul of a child raised by the belt. Bro, what happened, bro? What happened? Well, it's a lot of numbers, I gotta say. NIST. I heard of this name. What is this NIST? Institute of Standards and Technology. Okay, okay. They're what they are the people who does the SI units and stuff, I guess. Mm-hmm. Okay. How do I save this? Can I save it? Print page. Let me see if I could get it. What? Okay. I'm gonna save this on my university folder just to remind myself this shit ain't easy. This shit ain't this shit ain't normal. This thing is complex. God damn. God damn. Well, I better I better write my limitations of the Bohr model. Where is it? Well, I gotta say, I appreciate Snaggle Fluster. It's a great name, by the way, for dropping some serious lores. And Clonopin Commander, I really appreciate for checking out the stream. I was just wondering, I haven't seen you, so maybe did something happen, or it's like you were busy with your job. I don't know. Ah, this is my last question paper. This is my last answer sheet, and yes, it looks like some idiot wrote it. I agree. Particle and wave nature of electron field. So, yeah, after writing the Bohr model, I could stop. Bro. Yes. Yes, yes. I got the cheat sheet to everything. I got it for everything. Everything. What do you mean? Everything. Electrons move in a fixed orbital. Fixed circular orbitals. Energy levels around the nucleus. Okay, so Bohr did say there's a fixed path for electrons. Look up one Zoom tree of life. Okay. Mm-hmm. Wow, 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 wow. Click on any leaf. Let's go, apes! Oh! No? Is that okay? Here. Let's go, apes! The OG apes! Oh! Mm-hmm, mm-hmm. Occurrence! No way. What? What? Okay, it's just repeating, okay. Why here there's a lot of apes? Mm-hmm. Okay, okay. Oh, wait. Genetics. That's the NCBI, okay. Uh-huh, uh-huh. Bro got confuzzled. Yeah? What the hell? I mean, we got a lot of stuff going on. And there's too much data that it's taking time to load. No way. That's cool. That's cool. Uh-huh. Mammals start from here. Platypus. That's not a mammal, bro. That shit's crazy, man. It reminds me of what's it called? There's a number. Uh, the ratio, the golden ratio. Ah. Eukaryotes, species. There's not even names for these, okay? I mean, of course, how do you name all those? Holozoa, animals and more. Jellyfish, corals. Bilaterally symmetrical animals. Okay. What do you mean? Strange worms. Okay. Hexapods. Springtails. Winged insects. Wait, where are mammals? Gotta go a long way down. Ah. Where are the mammals? Did I lost them? Okay, it's part of aminotis. Okay. You know what? I never knew about this. One zoom tree of life. I gotta say, I'm gonna keep that, bro. I appreciate the recommendation. The more you know, the more you know. Okay, come back to Boar. Come back to Boar. Let me. Electrons can jump. Electrons can move in the fixed orbitals. Energy levels around the nucleus. Electrons can jump. Between orbits by absorbing and emitting energy. By absorbing and emitting energy. By absorbing. I feel like I need to read that every day. Limitations. Works only on hydrogen-like atoms. Oh shit, it's 130? I gotta eat something real fast, and I gotta look into the sequence analysis assignment. Okay, okay, okay. Works only for hydrogen-like atoms. Fails for multiple electron atoms. Okay, that makes sense. Cannot explain fine structure. Structure, electron spin, or chemical bonding. Okay, it's 1:28. YouTube, I'm gonna stop the stream because I gotta eat something. We cannot function without eating.